Now let's go ahead and talk about how to solve a system of linear equations. And the first method we are looking at is the graphing method. Now with this one, as I was talking to you about earlier, you have the ordered pairs, which will be considered as your solutions. Now if you have a set of ordered pairs and all these ordered pairs are solutions to the system, that set of all the ordered pairs will be called as your solution set. Now the one thing you have to keep in mind is when we are graphing these solution sets, on our equations, the first thing you will do is graph them on the same axis. You don't want to make two separate graphs. You will put them on the same axis plane. Now, the points on your line for each of these equations will satisfy the equation. All the points on your line are your solutions to that given line. Keeping that in mind, if you have an intersection point would be on both the lines, and that means it would be a solution for both the equations. Okay, so an intersection point being on both the lines will be the solution of your equations. Now the coordinates of this point, the point of intersection, or where the lines intersect, the coordinates of these points, that's your x and y, will be the solution of your system. Now keep in mind, when you are talking about two straight lines intersect at only one point. They cannot intersect at more than one point, and therefore for systems of this form where the two lines will intersect, you will have only one solution, one ordered pair as your solution of the system. Okay, so keeping that in mind, let's go ahead and look at this example for graphing to find the solution of our system of a line here. Now you can see we have these two equations. These are part of our system. Okay, you have x minus y equals 3 and x plus y equals -1. These are the two equations of a line that form our linear system. Now what we will do is go ahead and graph this line and then graph the other one and see what kind of a line they are. Do they intersect at a point? And then we can go ahead and find the solution. So what I have done here is I have set these up as tables so we can go ahead and find 2 points on each of these lines. We'll start with x minus y equals 3. I want to go ahead and find 2 points on this line that will help me graph. Now again, remember, back from chapter 7, we talked about finding the 2 points on the line. The easiest ones would be the x-intercept and the y-intercept. When you're trying to find the x-intercept, you make y 0. When you're trying to find the y-intercept, you make x 0. So if I make y 0 in this equation, x minus y equals 3, y being 0 will give me x equals 3. Okay, so that's my 1.30. If I make x 0, that will give me negative y equals 3, which is the same thing as y equals -3, and that will be my y-intercept, 0, -3. Again, if you're not sure how I did this, go ahead and substitute 0 for x. That will disappear and then you're left with negative y equals 3. The negative will have to go to the other side, and that's how you get the -3 here. If you're trying to find the x-intercept, make y 0. That disappears and you're left with x equals 3, and that's how you end up with your 3, 0 as the ordered pair. We'll do the exact same thing for the other line, which is x plus y equals -1. Go ahead and find your x-intercept and your y-intercept and see what values we come up with. So again, when I make my y 0, that disappears and I end up with x equals -1. And when I make my x 0, this will go, and that leaves me with y equals -1. So now we have 2 points on each line. We can go ahead and use these points to graph our line on the same axis plane. And here we have that. Okay, so let's go ahead and graph our first line. You have 3, 0, which will be the point right here, 3, 0. The other one is 0, negative 3. 0, negative 3 will be the point right here. And we can go ahead and graph these lines. Now, it's always a good idea to go ahead and put what line you just graphed. So go ahead and write its equation right there. This one was the x minus y equals 3, so that we know which line stands for what equation, okay? In the same way, we'll go ahead and graph the second line. Your ordered pairs were negative 1, 0, so that will be this point right here. And this is your negative 3, positive 3, positive 3, negative 3. Okay. Then our second point is 0, negative 1, which will be the point right here. So these 2 points will form our second line. We'll go ahead and draw this line. Again, don't forget to put your equation on that line. Now, looking at the graph, you can see that these 2 lines intersect at this point right here. That's your point of intersection. And if you can, you will see that the x coordinate is 1 right here. You can see this is your x coordinate. That will be 1. If you look at your y coordinate, it's this value negative 2. So this right here is your point of intersection. So let's go ahead and write that down. Okay, so you have let's see if I can try and get this here. Okay, so you have your point of intersection, which will be 1, negative 2. So as we discussed earlier, we said that the point of intersection will be the solution of your system, and since this point lies on both lines, it should satisfy both our equations. What we will do is use this point of intersection and just check our solution. So using these equations, we'll go ahead and plug in our ordered pair here and make sure that we end up with a true statement. So let's go ahead and check our solutions. We have x minus y equals 3. So x is 1 minus from the equation itself, and then y is negative 2. And that will give me 1 plus 2, which is a 3. So of course I end up with a true statement here. Do the same thing for your second line. X plus y equals negative 1. X is 1. Y is negative 2. And let's see if we end up with a true statement again. This will give you negative 2. 1 minus 2 gives you a negative 1. And there you have it. Another true statement. So now it is safe for us to say that this point of intersection satisfies both our equations, and therefore it is a solution of our system. So your solution set will have just one ordered pair, okay, and that will be but since we are writing this as a solution set, we put it in this set format. All right. Let's take a look at another example here. You have this system of equations. X plus y equals negative 5. X minus y equals 5. Just like we did in the earlier example, we will go ahead and find 2 points on each line and then go ahead and graph the 2 lines. Now let's go ahead and take a look at our first equation. You have x plus y equals -5. And again, you don't have to use the x and y intercepts always to find your 2 points. But as I said, those are the easier ones to work with, and so we'll go ahead and just stick with those. Now, to find the x-intercept, you make y 0, which will give you x equals -5. To find the y-intercept, we make our x 0, which will give us y equals -5. So you have your 2 points for the first line. Using the same thing, we will go ahead and find our x and y intercepts for the second line. And this will be when y is 0, x equals 5. Okay, so that's your x-intercept. When x is 0, you end up with -y equals 5. Taking the negative to the other side will give you y equals -5. Okay? So we have our 2 points for each line. We'll go ahead and graph these. This is 6, -6, let's see, a +5, and this is a -7. Okay, so you have -5, 0 for the first one, which will be this point right here. Then you have 0, -5 as your second point on that line, which will be this point right here. We can go ahead and draw our line through those 2 points, and this will be our line x plus y equals -5. Okay, now let's go ahead and graph our second line, which was 5, 0 as the first point, which will be right here. Then your second point was 0, -5. So 0, -5 is this same point right over here. So using these 2 points, again, we can draw our line through them. And this is x minus y equals 5. Now, as you can see right here, the y-intercept ends up being our point of intersection. You have 0, -5, and you could have actually seen that right here in the table itself, where both these points from each of the lines were the same points. So 0, -5 is our point of intersection. And again, it's always a good practice to go ahead and check your solution. So let's go ahead and check our solution here. You have your equations of lines and your point of intersection. Was of course 0, -5. So checking our answers, you have x plus y equals -5. This will be 0, y is -5. You end up with -5 equals -5. Of course, you end up with a true statement. Checking your answer for the second one, x minus y equals 5, which will give us 0 minus y is a -5. And the two negatives become a positive, and we have another true statement. So we can conclude that 0, -5 satisfies both our equations. And your solution set for the system is and there you have it. That's the solution of your system. Now let's just go ahead and do a quick recap of the steps that are involved in solving a linear system by graphing. Okay, so you have your first step, of course, will be to graph each of the equations in your system on the same coordinate axis. Okay, that's the first main thing. Then your second step is where you try and find the coordinates of the point of intersection for your two graphs, for your lines. And of course, you may come across a situation where you may not have a point of intersection. So if it does exist, you want to find the coordinates, and this will be the solution of your system. Now don't forget, this is the important part, you have to check the solution in both the original equations and then write your solution set. It's always a good practice to check your solution after you find it.